video here for lesson number 5 on Venn diagrams. So we're looking at Venn diagrams today. I know you've worked with Venn diagrams in other math classes, but we're going to look at them now in a little bit of a different way and look at them as a way of finding probabilities. The opening exercise is just a generic, straight up Venn diagram. Can you figure out what all the parts of the circles and things are going to be? So go ahead, pause the video here, see if you can fill in the Venn diagram with the given information about playing sports and being in the band. All right, so welcome back. Let's see how we did here. So the first item that they tell you is that 442 students play sports but do not play band. So that would be the part of the circle that just represents sports only, not the overlap. So it's 31 students are in the band but do not participate in sports. So that would be the part of the band circle that's not overlapping. 21 play both. So that's going to be the part that's overlapping. So that 21 students is kind of like being shared between both circles. 339 students participated in neither of them. So that number we put on the outside in the box that's showing that it's not in either circle. So the first question says, how many students participate in sports? So that would be both of these numbers, 442 and 21 together. Because even though these 21 students participate in band, they also are participating in sports. We'll do the same thing for the band circle. So the band circle is 21 plus 31. And the next question says how many students are in one or the other. So or means that we're going to add up all three of these numbers, because that's going to represent all the different people that represent just sports players, sports and band players, and only band players. So that's going to be one or the other. So that's 494. Now, this would be a Venn diagram that we would have used, I don't know, probably in 6th or 7th grade when we first learned about Venn diagrams. We're going to apply this same skill to probabilities. So Venn diagrams are a tool that we can use instead of using a two-way table. So what we're looking for is there's a couple ideas that we're going to look at today. We're going to look at the complement of an event, the union of two events, and the intersection of two events. A complement is the opposite of the event happening. So if I know the probability of rain today is 30%, the complement would be the probability of not rain. So this, we're looking for the word not. Union is one or the other. So that's going to be where we're adding up all circles in the Venn diagram. This is going to help us when we start looking at our probability rules in the next couple lessons. Intersection is where we're saying the two things happen at the same time. So in the opening exercise, union, this would be sports or band. Intersection would be sports and band. Right? So the union number was way bigger. The union number was 494. The sports end band number was only, I think, 21. So we wind up seeing this as more specific. All right, on the next page, I have a bunch of different Venn diagrams, and I'm asking you to kind of shade in what's being described below the box. So it says a student who plays a sport, S. So if I shade in the S circle, we're talking about all of these students. A student that plays band, we're talking about all of these students. A student that does not play a sport, this would be the complement of S. That's what that little superscript C means. So does not play sports. This is actually going to be a lot of coloring if you think about it, right? Does not play sports is going to be all of these people on the outside here, right? And then all of the band people that are not on the overlap of the sports bubble. These are all the people that don't play sports. A student who plays a sport and is in the band, so we have this symbol for and, right? So the intersection of sports and band, that would be just this part here. The union of sports or band, so sports or band would be anybody that's in either circle. So we have these two circles colored in, and students that play neither, that would be all of this on the outside. Again, I'm going through this relatively quickly because you should know how to do Venn diagrams. So let's take a look at this a little bit more specifically. So it says, suppose that 230 students play sport, 190 students play in a band, and 60 students play in sports and band. There are a total of 500 students in a school. Complete the Venn diagram by writing the numbers in the various regions. So go ahead, complete the Venn diagram. I'm going to pause the video. When I unpause it, you'll see the Venn diagram will be completed for you. Okay, so if we did this correctly, these should be our four numbers. If you have your numbers wrong, you probably didn't take into consideration that this 60 students is being shared by both band and sports players. So since there's 230 sports players, but 60 of them are in this circle already, right, we wind up getting 170 there. We're just subtracting 230 minus 60. The thing I always say about Venn diagrams is start with the most specific number that you have and then work towards the outside. So how many students play either a sport or are in the band? So you can add up these three numbers, 170, 60, and 130. That's going to give you 360 students. Or you could have said there's 500 total students, 140 play neither, so we can subtract those as well. How many students play in the band but not sports? That would be 130. Again, basic Venn diagram stuff here. Now let's apply this to probabilities. So it says, suppose that a student will be selected at random from the school. What is the probability that the student plays a sport and is in the band? So the probability of playing a sport and being in band is equal to some number of students out of 500. So without making a two-way table, we already know this number. It's 60. There are 60 students that play in a band or are in a sport. So if I do 60 divided by 500, remember our probabilities like to be rounded to 3 decimal places, we get 1, 2, 0. So about a 12% chance. So if we wanted to, we could take the same exact Venn diagram and we can put all the probabilities in there. So to find the probability of just playing sports, we would divide 170 by 500 and we'd get 0.34. If we wanted to find the probability of just being in the band, we would take 130 and divide by 500 and we'd get 0.260. And to find the probability of neither being in a sport, we would divide 140 by 500 and we get 0.280. Now, if you quickly add up those probabilities, you're going to get 1 because the total probability of this all together is 1, right? Whether you play sports or in a band or do nothing, those three things would add up to 1 when we're talking about probabilities. Now that we know all these individual probabilities, I can find specific probabilities. Like I can find the probability of somebody that is in band. So I'd add 0.12 and 0.26 and get 0.38. So there's a 38% chance of a student picked at random would be in the band. I can even find some really weird ones, like what's the probability of a student being just in sports or in neither sports or band. So you could add those probabilities up. So you could do a lot of different things with the Venn diagram. So now that we know that we can make a Venn diagram out of probabilities, let's try one. So number 3 says an online bookstore offers a large selection of books. 62% of the books are fiction, 47 are ebooks, those are electronic books, and 14% are ebooks but are not nonfiction. Let's create a Venn diagram. So when creating a Venn diagram, we start with the box to represent the total situation, and then we have fiction and ebooks. So it says 62% of books are fiction. That would be the entire F circle. So I don't want to start with that number. 47% are ebooks. And it says 14% are ebooks, but not nonfiction. So 14% are ebooks, but not nonfiction. That would go here, right? That's talking about the part of the E circle that's not overlapping with fiction. Well, that helps me because I know that there are 47% ebooks. So if I take 47 and subtract 14%, I get 33%. So 0.33 is this overlapping circle. And I know if the whole fiction circle is 62%, if I subtract 33%, I get 29%. Then to find the remaining number, the number of neither fiction or ebook, I would take 1 and subtract 0.29, 0.33, and 0.14. And I'd be left with 0.24. Then it says, what's the probability of F and E? That would be the intersection, so that would be 0.33. So there's a 33% chance of it being both of those at the same time. Union, that tells me I want to add up everything in the F or E bubbles. So if I add 0.29 plus 0.33 plus 0.14, I'm going to get a 76% chance of happening. The complement of F, so this would be not F. So I want to add everything that's not in the F circle. So I'm going to add 0.14 and 0.24, and I'm going to get 0.38. So there's a 38% chance of not being fiction at all. The intersection of not being fiction and not being an ebook. Well, if we're talking about not being fiction and not being an ebook, we won't want any of these numbers. The only number left is 0.24. That's the number that represents that. So that's the mathematical way of saying neither of those. We're going to skip number 4. It's basically exactly the same as the book question, just with fish. So kind of a waste of our time. And we're going to skip down here to number 5. Number 5 talks about another type of events. It's called mutually exclusive events. So mutually exclusive events have no common outcomes. An example of two events that are mutually exclusive would be me being an adult male being pregnant. The probability of somebody being pregnant is a realistic number. The probability of somebody being an adult male is also a realistic number. But the probability of me being both pregnant and being an adult male is a 0% chance of happening. That cannot happen. Those are two events that are mutually exclusive. So what would it be for two events to be mutually exclusive? We would have two circles to represent our probabilities, but notice they have no overlap. So describe two events that are mutually exclusive, the probability of a male and the probability of being pregnant. There's other examples, but that's, I think, the easiest one to explain. So here's an opportunity for you to pause the video, come back to the video, and check out and see how we did here with our homework. Shouldn't be too difficult, I don't think. All right, so welcome back. Hopefully you tried the homework here yourself, and we're just kind of going through answers. So the homework question tells us that we have the probability of being a pitcher, being right-handed, basically a simple baseball question. So it says the probability of a pitcher is 0.35, so that would be the whole P circle. Probability is right-handed is 0.79, that would be the whole R circle. The probability that he is a right-handed pitcher, so both, is 0.26, so we like that number. We'll start there. If I subtract the two other probabilities that they give me, I can find the other numbers here. So if I do 0.35 minus 0.26, I get 0.09 for the other part of pitcher. And if I do 0.79 minus 0.26, I get 0.53 for being right-handed. If I subtract those numbers from 1, I wind up getting 0.112 for being a left-handed non-pitcher. So, what's the probability of being a randomly selected right-handed person but not a pitcher? That's the 0.53. A pitcher but not right-handed, that's the 0.09. Neither right-handed nor pitcher, that's the 0.12. A pitcher or right-handed, so that's going to be the addition of these three numbers, or 1 minus this number, so that's going to be 0.88. A left-handed player, so somebody that's left-handed would be the two numbers that are not in the right-handed circle, so that's 0.09 plus 0.12, so that's going to be 0.21. not a pitcher, so that would be everybody that's not in the pitcher circle, so that would be 0.53 plus 0.12, so that would be 0.65. Explain why the event is a pitcher and is right-handed are not mutually exclusive, because the events can occur simultaneously. Right? So being mutually exclusive means that they can't both happen at the same time. Okay, they both can happen individually, but they couldn't happen at the same time. Okay, and that's it. Hopefully that video helped. Let me know if you have questions. Reach out to me via email, and hopefully I see you soon.